Okay, so let's now talk about exercise number 2. We want to check the injectivity and you want to check the injectivity and surjectivity of the following functions. You want to know whether these functions are injective and surjective, right? So part 1 of this question, this is question number 2. So part 1 of this question is f is a function from n to n. F is a function from, write this properly. So that is question exercise number 2. Part 1 of this exercise is f is a function from n to n that is given by f of x is equal to x squared, right? Now, so in order to check whether f is injective, basically injective means that injective means 1-to-1, right? It means 1-to-1 or 1-1 basically. So if the function is 1-1, that means that every member of the domain every distinct member of the domain has a distinct image in the range. That is the meaning of injective. And basically the condition that we use for this is that for example for every x1 and x2 belonging to x, which is your domain, if f of x1 is equal to f of x2, that implies that x1 is equal to x2. Meaning that if f of x1 is equal to f of x2, x1 is equal to x2, meaning that the same f of x's, if the f of x's are the same, that means that we are basically talking about the same points, right? Meaning that this kind of situation cannot exist if the function is injective. For example, you have all of these members here, a, b, c, d, and you have basically, for example, 1, 2, 3, and 4 here. So basically you could have the situation where a is mapped to 1, and b is mapped to 2, and c is mapped to 3, and d is mapped to 4. In this case, you can see that basically every distinct member of, let's call this x and y, every distinct member of x has a distinct image in y, and so that means that basically f is 1-1 or injective. On the other hand, let's suppose that, for example, you have this kind of situation. Let's suppose that you have, for example, let's say that this is 2, and the image of a is 1, the image of b is also 1. So this is still a function. There is no problem with it being a function. It's still a function, but now a and b are distinct elements of x, and they don't have distinct images in y. The image of 1 is the same as the image of b, and the image of a is the same as the image of b, and both are equal to 1, and therefore you cannot say that basically f is injective, right? So what we are saying here is that we are saying that if f of x1 is equal to f of x2, meaning that, so you can imagine that we can take this as f of x1 and if f of x1 is equal to f of x2, then x1 is equal to x2, meaning that if you imagine that there is two x's, x1 and x2, the images of those two x's are exactly the same, then those two x's must be the same, and that means that you're just talking about one of these lines, essentially, not two of these lines going to the same element here, right? So anyway, long story short, what you need to do is that you need to just simply use the condition that we have here. For every x1, x2 belonging to x, f of x1 is equal to f of x2 implies that x1 is equal to x2. And that means that then I can make this assumption in order to check whether f is injective. I can make this assumption that f of x1 is equal to f of x2, right? I can assume that that is true. If f of x1 is equal to f of x2, here we said that f of x is equal to x squared. That means that f of x1 becomes x1 squared. It becomes x1 squared. And f of x2 becomes x2 squared. So if x1 squared is equal to x2 squared, then what that means is that and when you want to basically solve this kind of equation, x1 squared is equal to x2 squared, this could be anything. For example, you could call it, I don't know, you can call it, for example, a and b, right? To make it simpler, I'm just going to call it, for example, a and b. The whole thing I'm just going to rewrite. So you can write, for example, the condition, you can write it as for every a and b belonging to x, any a and b belonging to the domain, f of a is equal to f of b implies that a is equal to b, right? And now I can assume that f of a is equal to f of b. If f of a is equal to f of b, what that means is that f of a would be a squared here. F of b would be b squared here. So a squared is equal to b squared. Now, this a and b belongs to the of course, to the domain of the function. Because when you have a function, you have the domain and you have the range here. You can call this also you can call this also the codomain. But of course, conditions apply. Provided that some conditions are met, you can also call it, basically the whole thing is of course called the codomain, but some part of that is called the range. Now all of these elements a, b, c, and so on and so forth, when we say that they belong to x, that means that they belong to the domain of the function, which is a, b, c, and so on and so forth. Now here we are saying that this n over here means that basically the domain of the function is the set of natural numbers. This is the set of natural numbers. And this n over here is telling me that the codomain of the function is also the set of natural numbers. So now when you want to solve this equation here, you need to solve it based on the fact that basically the domain and the codomain of the function are both the set of natural numbers. Otherwise, if they were different sets, for example, set of integers, or some set that you just made up for your particular purpose, then of course the way that you solve the problem would be the way that you solve the equation would be different, because here you're dealing with the square root function. And I'm saying that it would be different because you see over here, when you're dealing with the square root function, I'm sorry, with the function f of x is equal to x squared. You're dealing with the function f of x is equal to x squared. So let's say that this is 1, 1, 1, 1, and 2, 4. And 2, negative 2, 4 as well. So the function would be something like this. The function would simply be something like this. Now I'm going to talk about this over here for the whole problem, because in the rest of the problem we are going to be talking about the same, basically the same function in the set of integers, the set of basically real numbers, and so on and so forth. So we need to understand what we are doing here. Now, when we say that the domain of the function is the set of natural numbers, basically the domain of the function is represented by all of these numbers across this or along this horizontal line. So now, right now, the domain of the function is the set of natural numbers, meaning that you have basically 1, you have 2, 3, and so on and so forth. You don't even have 0 here. Now, if I said that basically the domain of the function is the set of integers, then of course you would have 0, you would have 1, 2, all the way up to infinity, and you would get also the negative numbers as well, all the way up to negative infinity, right? So you see that the problem would be completely different if you change your domain and range, basically, or codomain. Now, if now right now what happens is that basically since the domain of the function is the set of natural numbers, only this part of this graph is relevant for us, meaning that only this part of this graph is actually a part of our problem. Otherwise the rest of the graph is just not relevant, because these inputs are just simply not a part of the domain of the function, right? So what that means is that just you're simply working with this part of the graph. Now when I am basically solving this equation, a squared is equal to b squared, and basically a is some input along this horizontal axis, and b is some input along this horizontal axis, and both of them are positive numbers, because in the set of natural numbers you don't have any negative numbers. Then of course you could write it as a squared is equal to b squared, and take the square root of both sides of this equation, write it as the square root of b squared, and of course the square root of a squared, if you know that your a is positive, I know that a and b are both greater than 0, because a and b both belong to the set of natural numbers, right? So since a and b are both greater than 0, then I can simply write a is equal to b, right? I can simply write a is equal to b. So now you have assumed that f of a is equal to f of b, and you've gotten a is equal to b, which means that basically f is injective. F is injective, right? So that is how you solve this problem, given the constraints of your situation, meaning that But suppose that, for example, the same problem, we were working with the set of real numbers, in which case the way that you solve the problem would be a little bit different. So you want to, and of course we will talk about all of those parts in the rest of this problem. So far we know that basically f is we do know that f is basically is injective, right? Now in order for f to be surjective, we also want to know if f is surjective. In order to basically make sure that f is surjective, we need to basically make sure that it's basically a situation like this, meaning that you have your domain here, and you have your codomain here, and there are all of these elements A, B, C, and D, and they are mapped to some elements 1, 2, 3, 4, and so on and so forth. So suppose that A is mapped to 1, B is mapped to 2, C is mapped to 3, and D is mapped to 4. Now if that's all the if that is all the elements that you have, then of course you know that A is basically f is in this case f is injective, as we talked about it before. Now, since every element of the codomain is an image of some element in the domain of the function, then you can say that okay, so now in this situation, since every member of the codomain is an image of some element in the domain, then of course you can say that basically the function f is also surjective. And of course you can say that since the function is both surjective and injective, then you can say that the function is actually bijective, right? So that's the meaning of surjective, injective, and bijective. Now suppose that in the same situation I have another element here, for example 5. It's not the image of any element in the domain, right? It is not the image of any element in the domain. And so what that means is that the function it's still a function. There is no problem with it being a function, and it is still injective, but it is not surjective anymore. And since it's not surjective anymore, it cannot be bijective anymore. So it is only injective, right? So based on this, what we learn is that basically a function is surjective if every element of the codomain is the image of some element of the if every element of the codomain is the image of some element in the domain. Or you can say that basically if the range and the codomain are equal sets, then the function is of course surjective, because if every element that you have here is the image of some element in the domain, then your codomain, which is the whole set here, becomes the same as the range, and yet the range is basically the set of all of those elements that are basically the image of some element in the domain. So what that means is that if the range becomes the codomain, then what that means is that your function is surjective. Now, as you can see over here, so for example, I have all of these elements here. For example, 1 has been mapped to 1 because 1 squared is 1. 2 squared is 4, right? Or 3 squared is 9. So now you can see that, for example, 1 is some element that has been mapped to from this element in the, this is your domain, this is your codomain, right? Now, the element, for example, and 2 squared is equal to basically 4. 1, 2, 3, and 4 over here. So this is basically this point over here. So this is 2 and this is 4. This is 1 and this is 1. 2 squared is 4, 1 squared is 1. Now you can see that, for example, the element 2 which is a part of the codomain has not been mapped to from anything, because between 1 and 2, and since we are actually working with the set of natural numbers, so in the set of natural numbers you have 1, 2, 3, 4 all the way up to infinity. So between 1 and 2 I have no elements here, meaning that 1 is mapped to 1, 2 is mapped to 4. So nothing is mapping to 2 or 3. So now you can argue that basically 2 belongs to n. 2 belongs to n, but there does not exist any x in n. But there does not exist any element, any x in n such that f of x is equal to x squared is equal to 2, for example. And just that is just one example. There is countless examples that you can find here. And therefore f is not surjective. Right? So okay, so the second part of this question is again the same function, but now we are changing the domain and the codomain, meaning that now the function f, this is part 2 of the same question. Now f is a function that goes from z to z, the set of integers, to the set of integers given by the same rule, meaning that given by f of x is equal to x squared. Okay. Now again, we have essentially the same function that we have before, but now let's say that you have 1, 2, 3, and 4, and then you have all of these points, and 2 and 4 over here, and 4 over here, and so on and so forth, and you will get this function this way. Right? So now what we have is that, of course, you know that this z is your domain, this z represents your codomain, and your domain over here is represented by this horizontal axis, your codomain is represented by this vertical axis. Now if And now, since we are dealing with the set of integers, you know that integers are z is equal to basically 0, 1, 2, and so on, and 3, for example, and so on and so forth. And you have negative 1, you have negative 2, you have negative 3, and so on and so forth, all the way up to negative infinity. So that means that you have 0 over here as a part of your domain, you have 1, you have 2, you have 3, all the way up to infinity, negative 1, negative 2, all the way up to negative infinity. But there is no number between 0 and 1. There is no number between 1 and 2, and so on and so forth. And the same applies to all the negative numbers as well, right? Now, we said that basically, and the set of integers in the codomain is again the same story. You have all of these positive numbers, you have 0, and you have all of these negative numbers as well, which is pretty important in this particular problem. Now you want to know whether f is basically injective or not. So in order to decide that, you need to know whether for every a and b, for example, belonging to your x or to your domain, f of a is equal to f of b implies that a is equal to b, right? Now, if I assume that f of a is equal to f of b, then that means that a squared is equal to b squared, right? Now you want to basically we want to solve this equation and see what sort of relationship there is between a and b, because I want to know whether the assumption that I have made does imply this a is equal to b or not. Now here, since basically a and b both belong to the set of integers, as we know from here, a and b both belong to the set of integers. That means that a and b can be positive, can be negative, can be zero. Okay, so now the problem is that, erase all of these things. So now the problem is that, suppose that you write this, you know that basically, for example, 3 squared is equal to 9. Negative 3 squared is also equal to 9. So that means that basically, that means that the square root of 9 is actually equal to plus or minus 3, depending on what number you raise to the second power to get a squared. If a is less than 0, then a squared is going to be equal to, of course, a squared is going to be greater than 0, of course, right? Of course, as long as we are talking about real numbers. When we get into imaginary numbers, this doesn't work anymore. But if a is less than 0, a squared is going to be greater than 0. If a is greater than 0, as you can see here, a squared is going to still be going to be greater than 0, right? Now, in this situation, if I take the square root of a squared, that gives me a, and here a is, and in this case, well, a is less than 0. The a that I get over here, a is less than 0. Now over here, when I have a is greater than 0 to start with, and I'm taking the square root of a squared, this gives me the same a, but a is greater than 0 because I have started with a positive a. Meaning that suppose that I write, for example, 3 squared is equal to 9. Then when I write the square root of 9 to get back to 3, that gives me a 3 basically, right? So there is no problem there. Now suppose that I raise negative 3, raise negative 3 to the second power to get a 9. Now the square root of 9 here gives me a negative 3 because I started with a negative 3 actually. So that means that depending on what you started with, then of course the square root function gives you the same number and the same number back, except that you're using the principal square root function, which in every case gives you only a positive output, meaning that the principal square root function is denoted by the same notation, the same thing over here. But if you calculate the square root of 9 using the principal square root function, it will always give you only positive 3. There is no negative 3 for the principal square root function, meaning that for the square root function, basically your graph is going to be something like this, meaning that if you have, for example, the square root of 9 is going to be, for example, the square root of 4 is going to be 2. So the square root of 1 is equal to 1, and also negative 1. The square root of, for example, the square root of 4 is going to be equal to 2. So 1, 2, 3, and 4, and 2 over here. The square root of 0 is going to be 0, and then the square root of, for example, 9, 1, 2, 3, so you have a 2 over here as well. So the square root of 1, 2, 3, 4, 5, 6, 7, 8, and 9 is going to give you a 3's, which is basically this thing over here, this number over here, and negative 3, this number over here, So as you can see, it's going to be, and the square root of, for example, the square root of 9, the square root of 16 is equal to 4, for example. You get to 16 and you get to 4. So, long story short, if you use the square root function, you are going to have something like this. You can go to desmos.com and let's see what is f of x is equal to. F of x is equal to a square root of x. And as you can see, the square root function is, and actually this is only the principal square root function, meaning that the negative outputs are not given to you any here, which is basically this function here, right? Which is this function over here. This function over here. So otherwise, and of course you know that if I draw this part of the function as well, then of course it's not going to be a function in the first place, because every input gives you 2 outputs, so that would not be a function. But anyway, but the point here is that the principal square root function gives you only the positive outputs, doesn't give you any negative output. It assumes that your input has always been positive, so it always gives you the positive output. Now, so you can see that over here, if we talk about the square root function, not the principal square root function, but the square root function, if a is less than 0, then the square root of a squared is going to be some a which is less than 0. If a that you start with to get your a squared is greater than 0, then the square root of a squared is going to be some a which is greater than 0, right? And you have both of these situations over here. You have positive x's, you have negative x's. You have some positive x's are giving you some output, some negative x's are giving you the same outputs. And so for the same reason, we need to take all of those into consideration. Now, in this situation, what we have is a squared is equal to b squared, right? So that means that if I take the square root of a squared, it's going to give me plus or minus a, because a could have been negative here, it could have been positive here, it could have been negative here, because I'm simply working with the set of integers. The negatives are there, the positives are there, the 0 is also there. So then if I take the square root of a squared and write it as equal to the square root of b squared, so then the square root of a squared is plus or minus a, and the square root of b squared is plus or minus b, and well, you get only basically plus or minus a is equal to plus or minus b. That means that gives you, the logical conclusion from this would be that a is equal to plus or minus b, because suppose that you get plus or minus a is equal to plus or minus b, and suppose that you have plus a, take it with plus b and minus b, and negative a you take it with plus b and negative b, and then what happens is that then basically you have basically over here, this gives you a is equal to b, this gives you a is equal to negative b, this gives you negative a is equal to b, this gives you negative a is equal to negative b, right? So this means a is equal to b, this part over here. This means a is equal to b. This means a is equal to negative b. And a is equal to negative b I have already written over here. A is equal to b I have already written over here. So that means that plus or minus a is equal to plus or minus b is the same thing as a is equal to plus or minus b, right? So I can write this as a is equal to plus or minus b, which means that basically a could be equal to b, or a could be equal to negative b. Now, in the event that a is equal to negative b, then of course f cannot be injective anymore, and therefore you can conclude that f is not injective. F is not injective. And you can see this over here as well very clearly, because you have, for example, positive 2 over here and you have negative 2 over here, and you are saying that f of x is equal to x squared, meaning that, for example, f of 2 is equal to 2 squared, which is equal to 4 over here, 4, and f of negative 2 is equal to 4. right? So as you can see, you have this 2 and negative 2, positive 2 and negative 2 in the domain that are pointing to the same output in the range, meaning that you have a 4 over here, and so the image of 2 is 4, the image of negative 2 is also 4. So of course the function is not 1, 1 or injective. So that's clear to see here. Now the next part that we have here is that we want to know whether f is surjective. Is f surjective? So to decide that, we need to, of course, you can argue that, for example, there is for example 1 and 2. There is, for example, this number over here. 1 basically, the image of 1 is 1 here, so you have no problem there. The image of 2 is 4. So there is, for example, this 2 that belongs to your codomain that is not the image of any of these elements in your domain. Or there is even all of these elements here. That are not the images of anything. All of these negative y's in your codomain are not the images of anything, because your function, as you can see, goes up there. There is no graph down here. So then you can simply argue that for example, you can take, for example, the example of negative 2 down here, and that is actually a part of your codomain. You can say that negative 2 belongs to Z, but there does not exist any element X belonging to Z, but there does not exist any element X belonging to Z such that basically f of x is equal to x squared is equal to negative 2, right? Which means that basically f is not surjective. F is not surjective, right? Now the third part of this question is basically now basically we have the exact same function, but we have changed the domain and the codomain, meaning that now f goes from R to R. F goes from R to R, given by f of x is equal to x squared. So now again you have the same function. I mean, f of x is equal to x squared does not change. You have basically 1, 1, 2, 3, and 4, and 1 and 2, 1 and 2, and you have 0, you have 1, and basically this point over here and this point over here, and this is again your function. Okay, so that is your function. Now this is x, this is y. Now what has changed is that this domain is now the set of real numbers. This codomain is the set of real numbers. That means that now you have all the positive numbers, all the negative numbers, and you have the 0, 1, 2, 3, and so on and so forth. But between 0 and 1, you have countless numbers. Between 1 and 2 you have countless numbers, and between 0 and -1 you have countless numbers, and so on and so forth. So how do you solve this problem? Okay, so to solve this problem, first of all, for the part where we want to decide whether f is injective or 1, 1, basically we said that for every a and b belonging to the domain, if f of a is equal to f of b, that should imply that basically a is equal to b, right? Now, if I say that f of a, let's assume that f of a is equal to f of b, which means that a squared is equal to b squared. A squared is equal to b squared. Now again, if I take the square root of both sides of this equation, I get the square root of a squared is the square root of b is equal to the square root of b squared. Since a and b belong to the set of real numbers, and they can be negative, positive, so then basically, and b, basically the same story, b can be negative or positive, then that means that a can be equal to a is equal to plus or minus b. And since a is not only equal to a but also equal to negative, since a is not only equal to b but equal to also negative b, therefore f is not injective. F is not injective. Now, for the part that you want to decide whether f is surjective, you can argue that, for example, -2, you can argue that -2 belongs to R, which is basically this -2 over here, for example. But this is not mapped to anything because you can see the function is up here. So -2 belongs to R, but there does not exist any element x belonging to R, but there does not exist any element x belonging to R, such that f of x is equal to x squared is equal to -2, right? And therefore f is not surjective. So that means that f is not injective, it's not surjective. So that is that. Now the fourth part of this question is, okay, so the fourth part of this question is f is a function from n to n, natural numbers to natural numbers, such that given by f of x is equal to x cubed. Now f of x is equal to x cubed is this function here. It goes through basically 0, 0, it goes through 1, 1, it goes through -1, -1. And well, the function is basically some function like this, right? Now, in order to decide whether this function is injective, so of course you know that, for example, so 1 maps to 1, then 2 maps to basically 8. 3 maps to 27, and so on and so forth. And then -1 maps to -1, -2 maps to -8, -3 maps to -7, and so on and so forth. And so, of course, you can say that the function is, it is, of course, injective. But let's write the condition for every a and b belonging to x. If f of a is equal to f of b, that implies that a is equal to b. Let's see if that is the case. If I assume that f of a is equal to f of b, what that means is that basically a cube is equal to b cubed. Now, since a and b are, and of course, since I'm working with the set of basically natural numbers, of course, the only part that we are working with is basically only this part of the function. The rest of the function is simply not. We are not working with that. We are working with all the x's greater than or equal to 1 and all the y's greater than or equal to 1. That is basically the set of natural numbers. So what that means is that basically if I'm working with the set of natural numbers, then basically if I take the cube root of a cube, and if I take the cube root of b cube, so the cube root of a cube is going to be equal to a. So then negative a is not a part of the cube root of a cube, because a was not basically negative in the first place. And the cube root of b cube is going to be equal to b, both positive values, a and b being both positive values, right? So what that means is that since f of a is equal to f of b implies a is equal to b, therefore f is injective. F is injective. Now, for the part to decide whether f is surjective, so you can see that basically for example, over here, 1 cube is equal to 1, 2 cube is equal to 8, 3 cube is equal to 27. That means that there is at least one element here, 2, which is not the image of any of the elements of the domain, because 1 cube is equal to 1, 2 cube is equal to 8, and so there is no number between 1 and 2 that can be possibly mapped to 2, for example, and 2 falls between 1 and 8, right? So you can say that now 2 belongs to n, but there does not exist any element x belonging to the set of natural numbers such that f of x is equal to x cubed is equal to 2, and therefore f is not surjective. F is not surjective, right? So that is the fourth part of this question. So let's do the fifth part of this question as well. So the fifth part of this question is f is a function from z to z given by f of x is equal to x cubed, right? Now we have the same function. So you have 1, 1, and negative 1, negative 1, and so on and so forth. And this is your x and this is your y. And now the domain is the set of, basically, is the set of integers, which means positive numbers, negative numbers. The range is the set of integers, which is positive numbers, negative numbers. And but there is no number, for example, between 0 and 1. There is no number between 1 and 2. There is no number between 0 and negative 1. No number between negative 1 and negative 2, and so on and so forth. So that's basically the situation that we are working with. Now, basically, to decide whether f is injective, basically the condition that we have is set for every a and b belonging to the set x. If f of a is equal to f of b, that implies that a is equal to b. That implies that f is equal to b. That implies that a is equal to b. If that is the case, then you can say that basically f is injective, otherwise not. So now let's assume that basically f of a is equal to f of b. So if that is the case, then that means that a cube is equal to b cube. If a cube is equal to b cube, and if I take the cube root of a cube, and if I take the cube root of b cube, then what that means is that the cube root of b cube, then what that means is that since a and b are both negative and positive, so we have no problem here because we have no problem here because basically suppose that you take the cube root of, for example, you take the cube root of some if you take, for example, the cube root of, if you take the cube root of 8, it's going to give you a 2, right? Meaning that if you, or yet better to say, if you have 2 times 2 times 2, meaning that if your number that you start with is a positive number, then positive times positive times positive is give you positive 8. And so what that means is that the cube root of 8 is going to give you a 2, which is a positive number. On the other hand, if you start with a negative number, for example, negative 2 times negative 2 times negative 2, then negative times negative times negative is equal to negative, which is negative 8. And so the cube root of negative 8 is going to be equal to negative 2. That means that if a is positive, then the cube root of a is going to be positive. If a is negative, then the cube root of a is going to be negative, so you don't have to worry about signs here, right? So what that means is that now the cube root of a cube is equal to simply a, and the cube root of b is simply going to be equal to b. And so since f of a is equal to f of b implies a is equal to b, that means that f is injective. F is injective, right? And to decide whether f is surjective, to decide whether f is surjective, you can argue that, for example, you can see that over here 1 cube is equal to 1. 2 cube is equal to 2 cube is equal to 8. So between 1 and 8 there is all of these numbers like 2, 3, 4, 5, 6 and 7 that basically there is 2 over here and there is 1, 2, 3, 4, 5, 6, 7 and 8. So 2 cube is equal to 8 here. So the function is actually supposed to go through this point here, right? Now, if 2 cube is equal to 8, then there is all of these numbers like 1, like 2, like basically 2, 3, 4, 5, 6, 7 that have not been mapped to from any of the members of the domain. And so what that means is that basically you can argue that, for example, 2 belongs to Z. Basically 2 belongs to Z, right? But there does not exist any elements x belonging to Z such that f of x is equal to x cubed is equal to 2, and therefore f is not surjective. F is not surjective, right? Okay, so that was basically question number 2. In the next video we will talk about question number 3. I'll see you in the next video, and thank you.